So this is a different data structure which works with a logic called as LIFO, that is last in first out. So this could be either represented using arrays or linked list, right? So here we're going to again have the same structure what we have learned in the previous session, like arrays and linked list, but with a different functionality. Meaning that in arrays, if you just look into arrays, we are free to add or delete any item from the array, that is item from any position. So you can add in the very beginning of the array or in the end of the array. You can just add in between the elements in the array that is already existing. So we can just randomly pick numbers or elements that are stored in the array. So the same thing is true here even with the case of linked list. You can just do processing with any of the element that is there stored in the form of linked list. So here we don't have any constraint on picking the data and putting the data back into the data structure, array and linked list. Whereas here in the stack, which could either be represented as an array or a linked list, will not allow us to do that. Like it will just only allow us to add in the top of the stack and remove from the top of the stack. So stack could be viewed as an array like this. So here we're going to have a special pointer called as top, right, to access the elements in the stack. So here the special pointer, what it is going to do is it will just take us to the place where an item could be put into the stack, and the same pointer is going to be used for retrieving the item back from the stack. So this is a stack which is represented as an array. So you're going to have array declared as stack having some specific number of positions which could hold data in it. So stack, and say in general or in real time, like it is like having books arranged, like a pile of books arranged like this, right? You can have books arranged one over the other. So if you want to remove the book in the bottommost position, then without removing these books which are above this book 1, it will be difficult for us to remove this one, which is at the very bottommost position of the arranged books, the list of books, right? So why is it so? Like it is going to just fall down, right? We are not going to have the other books arranged in the same order if we are going to simply remove this first, right? So or, it could be like a stack of plates that are arranged in a buffet. Like always what we'll do, we'll just go take the plate at the topmost position. Will anybody go and pick out the plate from the bottommost position from the stack of the plate that has been arranged in the buffet? No. So that is actually the concept of stack. Stack is going to have some list of values stored wherein the user will be allowed to access only the topmost element. Say for example, if I have numbers like say, some values, say A2, B3, 4, C4, D8, E10. So if these are the elements that are stored in the stack, then this marks the topmost position of the stack. So always this top pointer, this is a special pointer which is used along with stack always, right? So this is the pointer which is going to get us the access to the elements stored in the stack, right? So this top pointer will always point to the topmost element in the stack. So that has to be remembered. Top pointer is going to point to the topmost element in the stack. Okay, so now whenever you want to get or retrieve an item from the stack, then it is only possible to retrieve item from the topmost or the position which the top pointer is pointing to. So I can only retrieve E10 first. Then this top pointer will obviously move down to point to the next. See, if this is being removed, then this D8 becomes the topmost element in the stack. So top pointer will come and point to this D8 then. So if you want to remove the next item, then you can remove D8. So in no case you will be able to remove A2 without removing all these elements which are above this A2. I hope you understand the logic. So that is why, say whenever I want to put something into the stack, so if I want to add some item into the stack, then I have to bring the top pointer to the next empty position and then put that value there. So if you just look into this concept, so whatever I put last, whatever I add last into the stack will be taken out first. So that is why I said that the stack is going to work with a logic called as last in first out. So whichever you add last, only that could be retrieved first. Clear? Just try to understand the logic here. I'll help you understand why the structure is really needed, where we actually use the structure in computing systems. Is this clear?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay, stack is basically a structure which could either be implemented using arrays or linked list. Implementation, I say how we are going to represent the stack in computer's memory. That is most important. We saw actually how this arrays could be stored in the computer memory and how this linked list is going to get stored in the computer memory. So similarly, how this structured stack is going to get implemented, or how this is going to get stored in the computer's memory. So we have two different structures basically which could help us to have the stack implemented in computer system. So that is one is arrays, the basic data structure which we've already seen in detail, and the other one is linked list. So in when I'm going to use linked list, then the structure will be like this. You can either use a single linked list or double linked list, it depends upon the user, but single linked list will suffice. So here top pointer will always point to the last element. So you have this head here which actually marks the bottommost position of the stack. So here whenever I want to add some item into the stack, say for example already few items are there in the stack, if I want to add a new item into the stack, then what I do is I'll just create a new a node and create a link like this, and also move the stop pointer to the next element, or point to the new element that is getting added. If I want to remove, then I have to use the previous pointer, because this is single linked list, I have to come back, right? So I'll just pop out this, remove this 40. Guys, am I audible? I think my audio has got disconnected.
Yes, ma'am. You are audible, ma'am.
Okay. Right. So this is how the linked list representation of stack is going to look like. Maybe I'll just help you understand in detail later, right? So in this class. Now let's see few primitive functions. So when I say addition into the stack, that is termed as push. And this is the terminology that we use with stacks. Whenever you add, addition is called as pushing item into the stack. And removal of data from the stack is termed as pop. So push and pop are the two primitive functions that are needed to get implemented in order to add or remove an item from a stack. Right? So pushing is something getting added into the stack, and popping is something getting removed from the stack. Right? I hope you understand this. So push is nothing but push. Actually, when I say push, then we are trying to put something into the stack. When I say pop, remove something from the stack. So this something could always be done only in the topmost position. That is most important. Right? So push in the top of the stack, pop from the top of the stack. Only that is possible. Pushing in between, so it's not possible, right? So nothing could be added in between. So why this kind of structure which has a lot of constraints? Even though random access is possible in case of arrays, why do you want to have a constraint imposed on that array and have the termed as stack? Where this is going to be used or is going to be useful for us? Any idea? So it is always easy for us if you just if you are allowed to add anywhere or remove data from any position in the array or linked list. That is going to be of great use for us. But here the stack, I told you that we have a constraint that you can only add or remove from the topmost position always. No random access is possible as in the case of arrays and linked list. So why do we need such a data structure which have this constraint, which is not going to allow the user to have a random access in the structure? Any idea? Guys, am I audible?
Yes, ma'am, you are audible, ma'am.
Okay. See, my PC is a mic is not working, so I have just connected with another client, external mic client. So if you are not responding me, then I doubt whether I am there online. Okay, then let me help you understand why this specific structure is really needed and how it is going to be useful in different cases in a computing system. So now coming to a function call. Let's forget about this, right? Now you have to, one thing what you have to keep in your mind is like addition and deletion is possible only at one end, that is at the top position of the stack, be it an array implementation or linked list implementation, right? So that's the constraint imposed on these structures in order to work as stacks, right? So have this alone in mind. So now let's see why this structure is really needed. Now let me explain that with an example. So how actually the function calls are happening when you write code. So normally when you write C code or C++ code, whatever it is, you go for writing a modular code, right? Modular in the sense you don't want to have all the functionalities done as one single program. Instead you try to have it as different modules, different functions, right? So whenever the function is needed, you call the function, right? So normally in the C program, let us take an example program, right? You'll have a main function, right? So which is going to have some set of declarations, definitions, and some statements, program language constructs, and you'll also have a function call. Say for example, I have function call to function 1, right? And this function call may be followed by some other programming language construct. I can have another function call also, not a problem. So you can now have whatever you want. So let's take for example, you have some main function with some set of specific statements along with a call to a function fn1, right? And this function has to be written somewhere in the same code, and you'll have some set of operations being implemented here in this function. And let's assume that you have another function, say fn2, right? And so you have this fn2 need to be implemented, right? So supposing you have another function call inside this, and you have fn3, and which is a plain function, does some basic operations and it gets done. So here in this case, how the execution will happen, how your system will understand that it has to go. See, normally the reason why we should have only one main in a C program is this, like the C program is going to have some set of functions. It is not a single program, that is one module wherein you're going to have all the operations done. You're going to have different modules which is going to make our job easier. So we are allowed to have different functions. So if you can have many different functions, then the compiler will not know from which point it has to start. So we have this one statement or one operation like which actually starts with the main. So this term main is going to help the system understand that this is the place from where the program should start running, right? So that's the reason why you should only have one main function in the C program, right? I hope you all know this. C program can contain only, C or C++ can contain only one main function. You cannot have more than one main function, and that is the indication for the compiler from the place where it has to start the execution, right? So now we have one main function, so it is easy for the compiler to identify the start position of the program. So it is going to start the execution from this point onwards, right? Now from this point the control flow is going to be sequential, so it is going to execute step by step, and the control flow is going to be sequential. And now you have call to a function fn1, right? So if there is a call to a function, then the control has to be transferred to this function. Control has to be transferred to this function. It cannot just proceed with executing the next statement, right? The control will get transferred to this function, right? So when the control has to get transferred, then what it does, it will simply transfer and start executing this function, and the flow here is again going to be sequential. Clear? Now here inside this function we have a call to another function, so the control will be transferred to that function, say fn2. Hope you are following me. So from this point onwards, the control flow is going to be sequential, and there is a branching to another function fn3, and here it just execute this function fn3, and this function ends. And what the system will do if the function ends, will it get stopped there? Will it be right if it gets stopped here? Guys, do you able to follow me?
Yes, ma'am.
What will happen on completion of fn3? After the execution of function fn3, where the control get transferred to? Or where should it get transferred to, in your opinion? No, these functions you have already written, and you know how the functions are getting executed in C, right? You would have worked with C compiler, C++, everything. At least some guesses. Your answer need not be necessarily right. You just give it a try.
Ma'am, it goes in a loop.
Loop? Do we
Goes
have
in a
any
loop
loop here? It goes in a loop in which place? In function f3? fn3?
From fn3 back to main function.
fn3?
Ma'am, it will continue fn2, ma'am.
It has to continue with fn2. Then where the control should go back? To which point in fn2? Will I go to the first statement of fn2? Guys, I just recommend one thing for you all to understand this in a better way. So you just try to execute a C program and use watch and trace. You try to trace what is happening when the statements are getting executed, and you'll know how the controls are getting transferred. Have you worked with Turbo C editor? Or you might be using some editor, right? Any idea, even for C, if you are going to use some Eclipse, something like that for C++, no problem. That even again helps you understand how the control flow is happening when the code is getting executed. You can just watch what is happening with every expression, and you can just go step by step, and you can see how the control is getting transferred from function to other function, how it is getting back to the function from where it actually went to, say, the called function. இதெல்லாம் ட்ரை பண்ணதே இல்லையா? I think at least there are 100 in meeting in the classroom. Huh?
No, we haven't tried it.
See, you have to explore as much as possible being a computer science engineer. See, if you want to become a computer science engineer, then you should have to explore.
The online component.
You are not audible, Pa? Somebody is trying to tell something. I could not hear you, probably.
C and C++, we generally use the online compiler.
You see, if you have PC at your home or laptop, whatever it is, you can just download the IDE or some Turbo C compilers or editors are free. You can always download it and use. Who stops you? So you have to explore a lot and learn on your own. So because everything cannot be done in the class, we can only give you guidelines in the class. because the time is very limited and you guys are not interested in attending class even if the teacher is ready to take class, right? So I pity you, you have to just spend time and explore a lot. So these things, being a computer science student, you should know. So when you go for placements, both ECE and you will be attending the placement examination for the same company, which is basically a computer science company, computer related company. But people who are interviewing you will expect more from than the ECE students from you, right? So you have to explore and learn. Okay, anyway, you have a lot of time now sitting at home. You'll have only 1 hour class for so maybe in between sessions you have time. You can just use those. Just a second. I think I got disconnected. Okay, later on you can try see how actually the function calls are happening using some editors or some developing environments later. Now let me explain how it works. So whenever I complete the execution of this function fn3, the system will know that it has to go back to the statement that is coming next to the callee function. This is the function called. So I call it as called function and this is the callee, right? So this is the statement which called this function fn3, right? So I have to know or remember the address to which the control has to get transferred after completing the execution of this function, right? So that is remembered by the system automatically and it will just transfer the control back to the statement from the point where it actually transferred the control when the function was called. I hope you follow me.
Yes, ma'am.
Okay, now let's see how the function this program remembers this address. See, every statement what you write will be attached with an address, right? Same. I assume the address of this statement that is coming to function fn1, coming next to function fn1 as L1. Let's assume this is a logical address. Just for an understanding purpose, I'm taking this. We are going to have physical address attached with every statement. Whenever you store something into the computer, then you need some address where this particular statement has to get stored. So I take this as L1, right? And here I take this as L2. And this one say L3. That is the address of the statement coming next to the function call, right? So here, what your system does is, or your compiler does is, it will just try to mark the labels or the addresses. And when the program is getting executed, a stack will get implicitly defined. You are not going to explicitly define a stack. You are not going to write a program to have a stack defined in the system and to use the stack in the during the runtime of the program. You are not going to do that. Implicitly, the stack will get defined. What the stack is going to have is, stack will normally be represented diagrammatically like this, right? I am using arrays, array representation of stacks. So this stack is called as address stack, right? And this stack will have the return address is stored and the values of the or the current values of the variables. So it is going to see if this function has got variable a, b, c declared, then on call to function fn1, the status of these variables, the current value of these variables are called as status. We use the terminology status, which actually gets us the, just a second, ஏதோ கால் வருது நம்பர். சரி So status of all the variables, current variables that are in use will be pushed inside the stack. So the value of this ABC and the return address L1 will be pushed inside the stack on the call to the function fn1, right? So now let us not bother about the variables, right? So I'll tell you why should we push these values also later, right? Now just for understanding how the stack is going to be used, let us just work only with labels, right? I'll come to this part later, right? Supposing that you're going to have a stack which is going to store all return addresses. So this is going to happen internally. You are not going to do that. When there is a call to a function, then immediately before transferring the control to that particular function, what the system is going to do is it will just take the address of the statement coming next to this function call and push that inside the stack. So stack was initially empty. Maybe I'll just to have a clear view. So here we'll have, so initially top is going to have a negative value in it, and array starts from say 0, 1. This is the array, right? And the 0, 1, 2 all are shown here, or the array indices, right? So there is a call to a function. The control flow is going to be sequential till this point, and there is a call to the function. And as I said, when there is a function call, the address of the statement coming next to the function call is going to get pushed. So whenever you want to push, you're going to increment the top pointer, bring it to the next free position, and you push L1. Right? Now, and when we encounter a call to a function fn2, when we are inside this fn1, what the system is going to do is repeatedly it's going to do the same thing. Like it will just try to push whenever there is a function call, it will just try to push the address of the next statement, and push that inside the stack. So L2 will get pushed inside the stack now, right? And control will be transferred after pushing this. And from here again, from this point onwards, the flow is going to be sequential. And when we encounter a call to a function fn3, then before transferring the control, this L3 will get pushed inside the stack. Okay. Now after pushing that, the control get transferred to fn3, and now from this point onwards, the flow is going to be sequential. And here inside this function fn3, we don't have a call to any other function. So this complete function will get executed, and when the system that is when the compiler or the on the box, excuse me please, அது கீழே இருக்க பாக்ஸில் இருக்கு பாரு, மருந்தெல்லாம் வச்சுருப்பாங்கல்ல அப்பா. ஓகே. So when it comes to an end, what the system will do is, it will go check now we have the top pointer here, right? We have pushed all these things, we have brought the top pointer here. Top pointer, as I said, it is always going to point to the topmost element. So top pointer is going to point to L3, right? So once we come to an end of this function, the system will not stop the execution of the program as such. It will go check whether the stack is empty. If the stack is empty, it is going to stop the execution. Or otherwise, what the system will do is, it will just pop out the topmost element from the stack. Only that is possible, because stack is a structure which has a constraint on accessing the elements. Only the topmost element could be retrieved. We don't know the addresses of other elements, right? So only top is going to be retrieved for us. So this will get popped out. This will get popped out, and we remember L3. And now it will take this value and transfer the control back to L3. L3 is what? It is the address of the statement coming next to fn3. So from here onwards, the flow is going to be sequential, right? and now it again comes to an end. This function fn2 comes to an end. So if this function is ending, then what it will do? Will it stop the execution? No, it cannot. Unless until the stack is empty, the execution will continue. So what it does is it will go check the stack again. And now this is not there anymore and top would have been brought down. Now this L2 is going to be popped out. Now with L2 in mind, the system will transfer the control to this particular statement. L2 is this. So control will get transferred to that L2. So after the execution of this function fn2, system is transferring the control to L2. And here onwards, the flow is going to be sequential. So this comes to an end. Now L2 is not there anymore in the stack. And the function has got over. The execution of function is over. But the execution of the whole program is not yet done. So we have a few more statements to be executed here in main function. So how it is going to happen? After completing this fn1, system will go check the stack. The stack has got some other value here, so that will get popped out. So it understands that it is written address, control to that address. It is L1. So here again, the flow will be sequential from this point, right? And now it continues the execution of main function, and once we are here at the end of the main function, again the system is going to go check the stack. Top is now -1. Stack has become empty. There are no items in the stack. All have been popped out, right? So it will just stop. It do not know what to do, where the control has to be transferred, so it will stop, right? And only this kind of structure which allows us to put something in the last and take out from the top is going to help us in this case. Say for example you have L3 at the bottom, L2, or you have the same thing, say L3, L2, L1. And what happened after completing fn3 if you just choose L1 and go? The statements remaining here in fn2 and remaining here in fn1 will never be executed. Clear? So that is not the thing we want. We want to see after I go complete the execution of function fn3, I need to complete the execution of the other statements which is following this fn3 and which is inside this fn2. This function has to be completed. So that will be done only if you just go in order. So if you just pick something randomly from here and transfer the control, will it work fine? Will it work fine?
No, ma'am.
It will not. We will go wrong, right? And coming to the variables, I said that when I started this, a stack is going to store the return addresses and also the status of all the variables in the current function. So why does it store the status of function? You would have studied about scope of the variables. Have you heard the word scope? Programming language start பண்ணும்போதே they'll tell you.
Yes, ma'am.
The lifetime of the variable, how long the variable is going to be alive, right? So here there is a higher chance that the same name, variable name, are appearing here in the other function also. I can use ABC here and ABC here in function f1 and ABC here in function f2. That is allowed. Is this allowed or not? Can I use this variable ABC here in all the functions? I can use, right? Because scope of this variable ABC is within this function. The value here in A in F1 do not have any connection with the value here in A in main. These two are two separate variables, right? So here if I am not going to use or push the values of this A inside the stack, when I am coming back I might just misunderstand the value here in the function F1, that is A in function F1, Fn1, and use it here in the main function. There is a higher chance. So what I do was, whenever I just go push something in the stack and transfer the control to other function, I will also transfer the contents of the variables or the current status of the variables that are in use in the function from where I am transferring the control into the stack. I hope I am clear.
Yes, ma'am.
Okay, if you are not able to understand it here, no problem, don't worry. I'll try to help you understand how stacks are used in quicksort And I think by the time I trace it, you'll be able to understand how the values are getting pushed and how we actually reuse the values from the stack, right? So don't worry about that. All that you need to understand is what is the need for the structure stack. So if you're not going to use the structure stack, then transferring the control back and forth in the programs wherein you have different modules or calls to many different functions is going to be difficult, right? So this is the one structure which is going to be implicitly implemented by the system. We are not going to explicitly write code to implement a stack and use it in the program during the function calls. The system itself will do it for you. These things are happening in the background, which we don't know, right? So this is how the stack structure is going to be implemented, and this is how the data or the written addresses are going to be pushed into the stack and used later on to transfer the control back to the called function or the callee function. Right? I hope this idea is clear. Only thing what I want you to understand is why or what is the need for stack structure. If array and linked list are going to be of more use, wherein the random access to the data is allowed by the user, why at all we go for using a same data structure in other name with a constraint over it? That should be understood. Hope you are clear with this. If you all are clear, then I'll move on to the next topic. That is implementation of push and pop functions. I need your response here in this point.
Yes, ma'am.
Yes, ma'am.
Thank you very much. How about the other section? I think it's Rangarajan and Saif for answering my response. Guys from A section,
It's clear, ma'am.
Understood, ma'am.
okay, let's move on to the next topic, that is functions over stack. Let's see how to write primitive functions, stack functions. So we basically saw that we need two functions to be written. One is push and other one is pop. Right? Push, I said, it is going to add. And pop is going to remove or delete. So if array is used for implementing, I said we are going to have two different implementations possible. One is using arrays and the other one is linked list. Right? Supposing you are using array to represent a stack, then how actually you use arrays to represent stack? It is just a normal array declaration. So you say if you want to stack, here it is going to be a static structure. So you need to have the size defined in prior, and here this is a dynamic structure. You don't need to define the size. Supposing I am using arrays, then I am going to simply say int s of 10, which means that I declare, I am just giving you a rough pseudocode here just to understand how this push and pop is going to work. Right? Declare an array, a stack with size 10. Right? And you also need to declare another variable, so which is a pointer variable here, or not a pointer. When you're going to use arrays, it is going to be integer because you're going to use index int top equal to, maybe you can define that as -1 or 0 if in case the array index is going to start from 1. Right? So you're going to have array. So instead of just drawing the array like this horizontally, I just draw it vertically for better understanding. Right? So you have top with -1 and array starts from 0. I hope this is clear. So if you are not getting something right here, you please stop me and you can get your doubts clarified. Right? So you can have 10 positions like this from 0 to 9. So if you're going to use arrays, then there is a higher chance of stack becoming full. Stack can become full. So when I store 10 elements, then I cannot just push 11th element in the stack because the size of the array that is declared is 10. So the other function associated here with the array implementation is stack full. So you have to check for stack fullness. So how can you check for stack fullness? When the top pointer is pointing to the 9th index. Guys, are you getting this?
Yes, ma'am, we are getting, ma'am.
Okay. So
Yes,
now,
ma'am.
yeah. Now let's see how to write this push function. We have declared an array. We also defined the top pointer. And now let's see how this push function will look like. So we need the stack to have the value pushed inside. And we also need the top pointer position to push the value inside the stack. And the actual value to be pushed. Right? So S is the name of the stack. And position, element getting pushed. X is element getting pushed. So when you're trying to push, so this is an array, right? When you're trying to push something inside an array, then you should first check whether the stack is now capable of accommodating any new element into it. Meaning that the stack should not be full. If the stack is full, then we cannot push any more item into the stack. So here, the first step what I do is, I check whether the stack is full. If stack full, if stack is full, then what I say, stack full, push not possible. Guys, I am just writing the pseudocode here. This is not any C program, right? This is just an algorithm what I am writing here. So if stack is full, so stack full is another function which is going to check for stack fullness. So how can the stack fullness could be checked? How the stack full function can look like? If top is equal to or n minus 1. If top value is n minus 1, then where n is the total length of the array. Right? Then return true. Else return false. It's as simple as that. If top is equal to n minus 1, where n is the length of the array or the actual size of the stack, then since the index starts from 0, I just check whether top is now pointing to the 9th position. If top is already there, then it means that we cannot increment the top and add anymore. So if top is, see in this case top is minus 1, the stack is empty. So we don't mind about the stack full is going to return true. So if this is, return false. If it is true, then we simply display this and stop. Else, what I do? What should I do here? I should go to a of 0 in this case, in this example, because top is minus 1. So what I do is, I increment top. And if I increment top, what happened here? Top will become 0, right? Then an S of top is the index what I am using here to point to the positions, various positions in the array. So S of top is equal to the item that is getting added, right? Now close. It's very easy and simple. Just have a look at this and tell me whether you are able to follow this. Is this clear? Okay, let us try pushing some data into the stack and check how it is working. Let's take the size of the stack to be a smaller one, say. let's assume the stack to be of size 4, right? So instead of 10, let's assume this to be 4. Now, what happens? I'll say I want to push 20, 30, 40 and 50 in this order, right? So X will take 20, and now I go, this is stack S and top is equal to -1 now. Stack is now empty. So how this function works? I take the array as one of the parameters and top pointer as other parameter and the item to be pushed into this function. Now I check whether the stack is full. Whenever I try to add, then I should confirm that the stack has got some empty position to get this element added. So I first check for that condition. If stack is full, then I simply say stack full and pushing is not possible. So this stack full condition is in turn. You can also just have if top is equal to n-1. This will also do, right? So nothing wrong in having, say, instead of having the function written separately, you can have this check directly done here. That is also correct. So nothing wrong here, right? So but when you want to have a modularity in the code that you write, then you have a separate function for stack full checking and stack empty and other stuff, right? So that you will not mess up things with other code, right? So either you can have this or this function written separately. This function is going to basically check for this condition only. So whichever you want, if you're comfortable with, you can use. And if this is the case, then you're going to do this. You say stack full and stop. But that is not the case here. What is top? Top is -1. -1. What is n? N is 4. N is the length. Okay. So total length of the stack that I have declared is 4. And it is not equal. So if this is not the case, then there are enough space there in stack to get this item added. That's the meaning, right? So we come to the else case and increment top. Why should I increment top? What happens if I just interchange the position of these two statements?
It doesn't get added to the array.
It will get added, but the previous item will get deleted. Say for example, your stack is top is here. Your top pointer is here, right? Now if you have this top coming next to push, so top is now pointing to the second element or element at index 1. So supposing you have 20 here, what you'll do, you just push the item first, that is you're going to override this 20 with 30. எனக்கு இப்போ மைக் ஒரு சவுண்ட்
தனி ஃபோன்லேருந்து பண்ணலாம்ல?
பண்ணலாம். You just override this 20 with 30 and then move, right? So in the case of top being -1, what you do is you just add something here as a junk. This X will go as junk because that is not a valid position in the array, right? So then you just bring this top here. Is this clear?
Yes, ma'am.
Yes, ma'am.
Okay, so that's the reason why you have to, because you should understand one thing very clearly here. We should understand that top pointer is always going to point to the topmost element in the stack. Topmost element in the stack. So if you are trying to add in the same position where the top is pointing to, then you're going to always override the top element, which is not allowed, which should not be done. We are going to lose data. So the first thing what you do is, once you find that the stack has got enough position to accommodate the new element, you increment the top and then push the item, right? So this is where people actually go wrong. So normally students will by heart, and because this is a very small program, the length of the program is very small, they can easily by heart. When they by heart, what do they do is, like they just bring this up and take this top equal to top plus 1 down, which actually will go wrong. The entire program is wrong in that case, right? So even if you are implementing the same thing, you can check that when you are trying to implement the stack operation, push function and pop function. You can try this in the system and check what is happening with the data that is being pushed. Right, having the stop coming as a second statement. You can just explore, right? So this is going to happen. So always you should have this coming, this top equal to top plus 1 coming first, and then s of top equal to x. This is in the case of array implementation. So I hope you understand what push is and how push operation is implemented. So normally what I say is, I just say push 10. So 10 will get added here. So the stop, these things will be all global variable. So normally when we write a stack program, we'll just have this array, that is stack and top pointer, everything as global. So all the functions will have access to those variables. I need not pass it in every function. I hope you all know what is a global variable and how global declaration goes in C and C++. Do you?
Yes, ma'am. You know, ma'am.
Okay. So this function may look like this. This function push may look, just have x as one only parameter in the function call. So being these things defined as a global variable. Okay. And now let's see how we can write a function for pop. How can we implement pop? What pop function should do? Pop is just the name. We are going to delete the top element. That is the idea behind pop. We just name, we use the terminology pop with deletion. Deletion in stack. That's it. It has nothing new. See, all that I want is, it is only a 2 or 3 line program or the algorithm. You are going to help me now to write. I am not going to teach you. Supposing you have, you can just give it a try. You have the top pointer here. And let's have the size of the stack to be, this is stack S, and these are the indices. Right, this is what we have. And now I want to write the function for removing item. This pop is delete function. And we all know this pop is going to get us only the element from the topmost position, not from anywhere else. Right? So 30 here in this example has to be removed. So what is the first step? You need not write code also. If step 1, you just let me know what should be step 1 and what should come as step 2. If you have step 3, what should be that? Just try.
Ma'am, first you may check is that is the stack full or not, and then we'll check for the position of 30. And then we may remove it.
You are closer to the answer, but the thing is, why should we check for the fullness of the stack?
Because as you said, ma'am, if once we have placed the element in the stack, we cannot remove it from it. Removing will be a bit difficult. And we have to check it if it's on the top, and if it what if it is on the bottom? What if we can't say the number 30 element 30 is on the lowest level?
No. The thing is, only if you're going to add something, then we should worry whether the stack is capable of getting this into it. And this particular data could be either put there or not, whether the stack has got enough space there to accommodate this new element. But here we are trying to remove something. So what could be removed? The item that is being pointed by top, or whatever top has got in it. Say if top, in this case top is going to have value 2. Just say s of top. that is going to get access to the topmost element. Right? So if I say simply S of top, I always say this is the only position known to me and this is the only place which could be accessed by me. Right? So if I say S of top, then I could take 30. It's very simple. So what I have to check here in the case of deletion is, so this is right, you know the top position. Top, see, as in the case of linked list, like you have head always known. Similarly here, top is always known to you. Right? Top will be given to you. You need not worry where the top is now to find out where the top is now. Top will be given to us. So it is just a single statement. Say S of top. It is going to get you the data. Topmost element. Just put it somewhere in order to retrieve it, I just take this data and put it in some variable X, which is going to be returned to the user on popping element. Right? But only problem what I will have is, when you will not be able to pop fails when the stack is empty. When there are no element to be removed, how can you delete an element? Right? So pop is not going to check for stack full, instead it is going to check for stack empty. If stack is empty, then pop is not possible. Clear? You need not bother whether the stack is full or not. If it is full, no problem. You are going to take from the topmost position. So if it is full, then you are going to have value till this point. You are going to have some X and Y here. Right? And top in that case will be pointing to this Y. Top is not going to be there. If it is full, then what bothers us? We are not going to add. We are going to simply remove. Right? Simply say S of top. So you get Y. That suffices. So that is more than enough for me. And what next should be done? This Y has been removed. And this top pointer should not point to this Y anymore. Instead, it should point to the element below this Y. So what I have to do next? This is not the top. The new top is this. So what has to be done here? Bring the top from 4 to 3. So decrement top. Okay. So step 1 is check right. So if the stack is empty, then no popping possible. Else pop. Meaning that take S of top and put it in some variable X. And what is third step? Top should not be at the same place after you remove the topmost element. It should be decremented, brought down. Top equal to top minus 1. And step 4, return X. That is the popped element. Right? So, function is going to look like this. It's well tried, I think it's safe. You have to check for a condition but not full. Instead, it is empty. Pop X. Right? If stack empty, do what? Pop not possible. Return false. X will have 0. Then else. Either can have else or you can, because since we have written here, you need not have else. If this is not the case, then automatically come to the next step. Here what you do is X equal to S of top and top equal to top minus 1. Return X. That's it. Stack emptiness, how it is going to be checked? I write the function stack empty separately here. If top equal to minus 1, this is in the case of REs. If top is equal to minus 1, then return true. else return false. Right? So here top is not equal to -1, so it is going to return false. If this condition fails, it will come to the next statement. If this is true, it will return false. Else it is coming to next statement. Next statement is retrieving item. Right? So it is not just enough to retrieve the item, but also you have to bring down the top pointer to point to the next topmost element after you delete something from the stack. So you have to have this top equal to top -1 coming next to this statement. So you can now find the difference in the push function. Top equal to incrementation was done first, right? And then we added the element. Here you first retrieve the element, process, and then decrement. Is this clear? Others?
Yes, ma'am.
Okay. So here we have seen what a stack is and what is the use of stack and why the stack structure is needed, and we have seen the primitive functions like push and pop in the array implementation. Now let's see how the stack could be represented using linked list and how the functions are going to be written. See, normally when you go for implementing any other structure using a linked list, it is always it is always better to use doubly linked list, because moving back and forth in doubly linked list will be easier. Whereas in the case of single linked list, as we've seen in the previous classes, like you're going to use two different pointers in order to gain access to the previous elements. There you're going to use current and previous. Whereas in the case of double linked list, being at one position, you'll be able to move both in the forward and reverse direction. It's going to make our job easier. So always we go for using double linked list for implementing any higher level structures using the primitive structures like linked list and arrays. I hope you follow me.
Yes, ma'am.
Okay. Now, let's see how this push and pop is going to be written with double linked list. See here, diagrammatically the stack is going to be represented like this in the case where you're going to use double linked list. We have one pointer, which actually we termed as current or PTR in the previous classes, is going to be retermed as top, right? So it is nothing new here. It is just a pointer used for traversal. Okay. Head will get us the bottommost element and top is going to get us the topmost element. Here, supposing I have elements like this. Right? The other case possible is stack is empty. When the stack is empty, then you could have, if this is a so no, let us not get confused with circular. When stack is empty, one possible case is head being null, and if you're having a header node, then it is only head node. We are not going to work with circular list, right? I hope you understand the difference between these two. We have seen different kinds of linked list. This is a linked list which is grounded with a special node called as head node, and this is a list, normal list, which do not have a special node called as head node. Instead it has a head pointer which is marked as null in the case of empty list. Okay, so if the stack is empty, then one case that is possible is having head moved with null. Or the other case that is possible with a special header node having this head pointer pointing to the header node and no other links to it, right? So to make the job very simple and easy, I'll just take the normal list without a special, because that is not needed here. So let us not confuse things. So I'll make it very simple. So if the head is null, then the list itself is null and the stack is empty. If head is not null, then the stack has got some item and we are going to have top pointer pointing to the topmost item in that case. So the example what I have chosen here, the head is not null. So if in case the head is null, then you are going to add the first element as the head node and mark it with top. Right? So if you want to have it as, because just to check for the emptiness of stack, we need to have this head marked. Right? Or otherwise we will go wrong. The top will be null otherwise. Both the things are okay, but this will be easy for you to understand because you have already worked with head being null to check for the emptiness, right? So I just have this head equal to null. So when I try to add something here or push, what I do is I'll create a node, populate the node and append it. This is what I'm going to do, right? So these three things will get the node added newly there or get your push done. So I want to add, supposing I want to add 50, then create node with 50. So if you're going to create, then you're going to create a structure like this whose address is known to you. The address is I, right? How do you, that is what I have just populated, right? So I have just created, populating the node is like data of node I is 50, left link and right link of I. Left link of I and right link of I is equal to null. This is populating the node, right? And now I want to append. How do I append? How can I append this? I have the node whose address can I create these students? This is just writing normal linked list appending code in order to push. How do I create this link? I know the address of this node that is there in top. I know the address of the node to get added, that is I, right? So this link 1, maybe I'll name this links, link 1 and link 2. So link 1, how can I create this link 1? I have to access the right link of top and put what? Address I. So I create link 1. And what is link 2? Link 2 is pushing the address of this entire node into the left link of I. So left link of I should be moved with top. Clear? So just add this, or otherwise I can just show you like this also. Right, this is top. Now you have what? 10, 20, 30 and 40. This is top, not pop. So how do I add? I want to add another new node here and make this node point to 40 and make this 40 point to 50. And I know the address of this node that is getting added because that is the one which is created by me. So I know the address of it. And I know the address of 40 also, that is now there in top. So this is left link and this is right link. Move left link of this should point to this 50. Arrow mati potte. Please try to change this. So left link of this 40 should point to 50, and 50's right link should point to what? Point back to 40. Right? So just have this statements written, that will get you these things back. Clear? Any doubt in this? Guys? Okay. So here, so if you just draw it horizontally, it will be easier to understand. That is why I've just drawn like this. Right? So it is just adding on the top or adding at the end of the list. Clear? So here, what I'm going to do is, for pushing again, should I check for stack fullness as I did in the case of arrays?
No, ma'am.
Why no?
Because we can dynamically add it again.
Very
and
good,
again.
exactly. Because we can dynamically add, have any number of nodes created. The structure is dynamic, right? So you'll never go full. Stack is always going to have enough space to accommodate any new coming data. So let us not bother about checking for stack fullness. Only if this I has got value null in it, then it means that we are out of memory, right? There are cases wherein you go out of memory, like when the memory is getting dumped with some unnecessary data. That is when your processor is not, when your processor is not killed, and when your processor is busy working with some other function within a loop, not coming out of it, then memory core can get dumped. So only in that case, this I will be returned with null value. You will not be retrieve any memory from the heap. So in that case, memory full will happen. So which is not a normal case. So normally you will be returned with few memory locations whenever you request for. So stack full need not be checked for. Okay. So memory core dumped or error on the core. Have you ever experienced that? Core dump. This is a common error which actually will be experienced when you are working with recursive algorithms. You will not have control over the process, and you will not know where the control in the execution has got transferred to, and the processor will keep on processing the same stuff, dumping the code. Have you ever experienced this error? The system will simply hang showing that code dumped. யாருக்காவது வந்திருக்கா? You are all very poor programmers. Okay, you have to explore a lot. All these bugs has to be experienced, or otherwise you will not be able to fix it. Only if you experience some problem, you will understand and you know how to overcome that problem. Or otherwise it is difficult. So this is a very common problem which will occur in the case of functions which are not written properly, recursive functions which are not written properly. So try to have a better experience in coding so that it will be easy for you to crack the interviews later on, right? You may think that it is too early for me to tell you about the interviews, but this is the right time when you can start learning your coding skills or improving your coding skills. You have to start learning code. I don't know about the skills. You don't have any coding skill at all. So it needs a lot of practice. You have to spend a lot of time to write the code and check what is happening. Your code need not be correct at the first step. It need not be correct in the second or third or nth number of time also, no problem. Just try to understand what is happening on the code, with the code what you write. That will help you understand the language in deeper level. Okay, let us not waste time on that. Let me come to pushing. Push item into the stack when the stack is implemented using a linked list structure. So we are not going to bother about stack fullness because we always assume that the system is going to get us some enough positions to add the new item. So push X. Then what? Then what? Assume that you have created a node and the node's address is I. So if you want, you can have that also. So I'm just making everything global here. I is known to us, top is known to us, head is known to us, everything is known. Right? So I can simply say if top is equal to null, then stack empty. And this is not needed here in push, right? Because emptiness is not going to help us to push any item, right? But what is needed here? What is needed here? You have to create two links. When the stack is empty and when you are adding a new item, what will you do? What will you do?
The links are null.
Huh?
We check whether the links are null or it has a null.
This is the case where you have to check for top equal to null. If top is null, then the stack is empty, right? So if the stack is empty, then you are not going to create the links. Just have the I just added and pointed by top. So if top is equal to null, then what you do? You just make top equal to I. You need not create the links. That's the reason why I check for top is equal to null. Right? It is not for checking whether the stack is empty. Even the stack emptiness could be checked with this condition top equal to null. I don't know how many of you are following me. I repeat anyway. So here, why I check for this top equal to null is, instead of having head is normally known to us. Whenever we create a linked list, we always create a head node. But it is a question mark here whether you need to have this head or not when it is used for a stack representation. And that is what I am helping you understand here. So even if you are not having this head, it is going to be and we don't need to understand where actually the first element is, because the direct access to first element is not possible at all in the case of stack structure. So this head is not going to be of any use for us. So you need not necessarily define this head. Even if you define this, it is not a mistake here. You can have, but it is not needed. So whenever something is not needed, then in order to reduce the memory that you are going to use, you are not going to declare it. So let us not declare head. You can directly use top. So when the stack is empty, this top pointer is going to have null, right? So why this emptiness has to be checked here is, when you are adding the item as the very first item in the linked list, then you don't want to create these two links. Do you need to create these two links? No. So you can simply check if top is equal to null, then make this as the top and stop, right? Else what you do? You return here. I just rewrite this. If top equal to null, top equal to I, you are inserting this, right? Else what you do? If top is not equal to null, then you have enough elements there. So you have to attach this as the last node. So if you want to attach this as the last node, then you have to create these two links, right? So you have to make this topmost element point to this element, right? So what is there in top? Right link of, guys, do you able to follow me? Okay, right link of top should be moved with I, right? So I have created this link. since we are using a doubly linked list, I should also make this new node point back to the previous top. Why this is needed is deleting will be, or popping will be easier if you're going to have doubly linked list, because you need to decrement or move this one position down. One second, excuse me please. Sol Sandhya. The class கடைக்கு போயிட்டியா? இப்போ என்ன டைமு? அது நான் அனுப்புகிறேன், ஒரு 5 minutes அனுப்புகிறேன். ஓகே அங்கே. Okay, so here I should make this I point back to 40, right? So what I do is I should make the left link of, for creating that particular link, I should make left link of I point to top. So move top to left link field of I. So I create this reverse link. Okay. Now what is next? Should I have to write any other statement or simply close? Are we done here with these steps?
We have to update the top pointer.
You have to update the top pointer because top is still pointing to 40. We have created these two links with these two statements. Very good. We have created these two links with these two statements. That is 1 and 2 has been created with these two statements. But still the stop is pointing to this 40, which should not point to this 40 anymore after adding this new note here. Supposing this is 50, then it should now point to 50. So you have to move top. How can I move top? How can I make this top pointer point to 50? I should make this top point to 50, which means that I have to take the address of 50 and put in top. Where do I have address of 50? I have address of 50 in I. So both I and top are pointer variables. Both I and top are pointer variables, and this left link and right link are pointer positions which can hold addresses. So it is right to have this I getting moved into R link of top and top getting moved into L link of I, and having this I moved to top is also right. All address assignments, it works fine. I am not just moving any normal variable into address position, right? Address moved into position which can hold address. Hope this is clear. So I just moved top pointer to point to this 50 newly. So this is not going to point to top anymore. This is not going to be the top element anymore. Clear? So top will point to 50. Hope this is clear. Guys, if you are not clear with linked list operations or algorithms in the linked list, then it is going to be difficult for you to follow this also. So take some time to go through the algorithms in linked list what you have seen, and it's very easy to understand. It only needs some time for you to sit and go through to have a clear understanding. So try to spend some time on going through that and understanding the concepts. So all other things will become very easy, because I'm going to use only linked list structure for other structures also, like trees and others, right? So it will be difficult if you are not following the address operations in linked list. So let me know if you are not following anything in the linked list. I will repeat, no problem for me, because that needs a better understanding to understand other structures. Is this clear now? Shall we move on to the other function?
Excuse me, ma'am. Excuse me.
I think already I have taken 5 or 10 minutes extra or what?
It's 11:05, ma'am.
11:05. Yeah, I have to close because I have class for the other section in the next slot. Shall I complete push and stop? Will it be okay? Or shall we stop here?
Now you can complete it as soon as possible, and you can complete it. Or else if you think it will take time, then you can
I
stop
can do
right
it
now.
faster, but the thing is, you have to get it faster. I can do it very quickly. It doesn't take much of my time. It needs just 2 or 3 minutes for me to complete. I will do it here in the same screen. Shall I? So popping here, pop is to remove the item. So let's I'll do it quickly. அப்போ எனக்கு அடுத்த கிளாஸ் ஓடி போயிடும்.
இன்டைரக்டா எடுக்க வேணாம்னு சொல்றாங்க. எதுக்கு அவங்க போட்டு இப்ப எடுத்து விட்டுறாங்க?
ஐயோ அப்பா ஃபோனை வேற யூஸ் பண்ண அடிக்கிறாங்க. இல்லைங்க நம்பர். Okay, so here let us take some values. Popping is removing items. Class நடக்கிறப்போ so when I want to pop, what I do is I'll just decrement the top as I did in the case of arrays. So arrays, what we did, array representation of stacks, we decremented, we just removed the item. This was the thing done. So we have taken the item from the topmost position, pushed into some variable and decremented the top pointer. So similarly here, take the read item from the node that is being currently pointed by top and move the top pointer 1 position down. It's as simple as that. You have to read. So how do I read? So I just take data of top and move it to x, popped. This is the step for popping the element. I'll just pop out the element. And the next thing is S.
Ma'am,
சொல்லு ஐஷா.
பசங்க எல்லாம் டைம் தப்பு நடத்துறாங்க. நீங்க எடுத்துட்டே இருக்கீங்க. ஸ்டாப்.
இல்ல நான் கேட்டேன் பசங்க கிட்ட இத மட்டும் முடிச்சிரலாம் மேம் சொன்னாங்க. அதனால எடுக்கிறேன்.
அப்படியா? இல்ல நிறைய பேர் இங்க எக்ஸ்ட்ராவா எடுத்துட்டீங்கன்னு சாட்ல போட்டுட்டே இருக்காங்களே, அதனால சொன்னேன்.
அப்படியா? சரி, if they are not interested, let me stop here. But ஏன்னா இது ஒரே ஒரு தான் அங்க தொங்கிட்டே இருக்கும். அப்புறம் லாஸ்டா இல்ல I have to again start this in the next class. இது முடிச்சிட்டேன்னா we'll start with the next algorithm ல.
நீங்க கம்ப்ளீட் பண்ணுங்க. நம்ம இத கூகுள் இதுல போட்டுறலாம். கிளாஸ் ரூம்ல they can look at it and if when they are interested. Hello.
From the same thing again. இது மட்டும் இருக்கும் அதனால தான். Okay, I'll completely. Thank you. So here the element has to be popped is nothing but reading the topmost element and just returning it to the user. So it is not just enough to read and return, also I have to make modification here in the top pointer. So what modification has to be done? I have to bring down this 1 position because the next element down here in the stack should become the new top. This has been removed. So I have to delete these 2 links. So how can I delete these 2 links? It is deleting a set of links here in the linked list when the stack is represented using linked list. So how can I do this? You need not explicitly delete. So as in the case of deletion, what we've seen in the normal linked list, we are not going to explicitly delete, but instead we are going to create some new links. So what is the new link that I'm going to create? I'm going to make this 30 as a new top. So make this top pointer point to this 30. So how can I just pull this top pointer 1 position down? So top should be moved with a new address or address of 30. Where can I find the address of 30? It is there in left link of 40, right? So 40 is now currently being pointed by top. So I have the address of 40 here in top and I can easily access the left link of top in that case. So what I do is I just move the content from left link of top to top. So left link of top has got the address of 30. So now that is getting moved into top, which makes this top pointer to come and point to 30. So this is the easiest method to delete. If you're going to have the doubly linked list if you're going to use this doubly linked list for representing the stack, then this popping is going to be very easy. If you're going to use a singly linked list, even singly linked list can be used as a stack, no problem. The thing is, you have to use 2 pointers. You have to keep track of the previous element also, previous to top. So only that will help you to bring down this top 1 position below here in the stack, or otherwise it's going to be difficult. So to avoid that problem, we make use of doubly linked list. So here, is there a chance of getting this stack empty? Should we check for stack emptiness? As in the case of arrays, how can we check for stack emptiness if we need to check for? Can you please make it faster? It is getting late for me. I have the other class in the next session. Will the stack ever become empty? Anybody there?
Yes, ma'am.
Will the stack become empty? I said the stack will never become full because it is a dynamic structure unless until the core is getting dumped, you are going to get the data, that is memory location allocated for you. And you need not check for stack fullness. And that's the case, be true here for stack emptiness also. Stack will become empty. If you are going to remove 40, 30, 20 and 10, do you have anything else here in the stack? All the nodes will get removed. Stack will become empty. So here how the stack will become empty. So when you are removing, see, supposing you are removed 40, 20, 30 and 20, and now you have the top here pointing to 10. So when you remove this 40, what will happen? What is L link of top? L link of top is got null. So top will become null if you are removing 10 also. Right? So top will become null if you are removing the last node from the stack. So in that case, the top is going to have null moved into it. So stack emptiness has to be checked. No data is available here after removing all the elements. So if top is equal to null, then stack empty, no popping possible, error, right? Else, what you do? Else read the data from the topmost position by the statement. Data of top will get you the data, content of data field of that particular node which is currently being pointed by top, and it will get moved into X, right? And you have to bring the top pointer down. So how do you do that? That is using the statement. So move L link of top to top, so you will bring it down and return X. We are done. Any doubts here?